Okay, so this is linking in with one of the experiments that you should have seen. It's got an overlap with the electrolysis of water. And the first thing it says is, why is the water acidified? So the reason the water is acidified is water doesn't contain ions, so we add ions in order for it to move. Okay, so why is the acidified water an electrolyte? That's because it contains ions. And then to get the second mark, we need to say which are free to move. So it contains ions which are free to move. Okay, so hydrogen collects at the negative electrode and oxygen collects at the positive electrode. Which of these should result after 10 minutes? So if you remember, water is H2O. So when it breaks down to produce hydrogen, I would expect to have double the amount of hydrogen than I would do for the oxygen. And it tells me that the hydrogen is produced at the negative electrode. So if I just check in here what I have got, this option A, then this would be the hydrogen here, and that is twice the amount of that. So option A is a possibility. Here they're both the same, so it's not going to be that one. That's not. Shouldn't put a cross there. I'm going to put a cross on there. That's not going to be the right one. Here, this one's got less hydrogen. That wouldn't be right. We've already said that hydrogen has to be twice the amount, so it's not going to be that one. And here again, hydrogen's got less, so it's not going to be that one. So the sensible option is option A. Okay, next little bit, complete the balanced equation for this. Right, if you don't know this, you need to go away and learn it. It comes up all the time on a higher paper. I'm going to show you how to work it out if you forget, but I'm going to put the answer in as well. So if you're struggling with this, to remember it, and I do really advise you go away and learn it, what we've got to do here, so we're trying to get rid of charges. So what happens is, we've got to get rid of this OH minus charge. So a second of these molecules comes along, and I've written it back to front for a reason, because what's going to happen here is these two will join together, and that is going to produce water. But what it does do is leave me with an O minus left over. So I get another one coming along, OH minus, and this time these two join together, and that's going to give me oxygen, which is fine. It doesn't have a charge, so that's okay, but this is left with a charge. So we'll get another hydroxide coming along, OH minus, and what these two do is they join together to make H2O. So if you check, we have got 1, 2, 3, 4 hydroxides making 2 lots of water. So here let's put down 2 H2O plus oxygen. There's my oxygen, plus 1, 2, 3, 4 electrons. So I've got here plus 4E minus. In terms of marks, I think what they're doing is getting 1 mark if you've got the H2O and oxygen correct and balanced, and then a second mark if you've got 4 electrons there as well. Okay, so copper sulfate was electrolyzed for 10 minutes using copper electrodes. This figure shows you what is happening, the appearance and the mass of the electrodes afterwards. Okay, so describe what should be done to the copper cathode after it's been removed from the copper sulfate before its final mass is determined. So what you would do is you would, at this situation, here we go here, so this is increasing mass, so you would give it a wash, and you would then leave it somewhere to dry. What you wouldn't do is wipe it dry, because you brush off the copper that's formed on its surface. Okay. It says explain in terms of ions the change in mass of the cathode. So what happens here is that the cations, the copper ions, are attracted to the cathode, and they pick up 2 electrons to make them copper, which is neutral. So this is forming copper atoms. And what that means is on your surface of your electrode, you've got a brand new layer of copper forming, which is why that's going to cause the mass to increase, because you've got new copper forming on the surface. So explain in terms what happens. So in terms of explaining this, you can write the equation down as I've done here. You would say here that the copper atoms, so copper ions, so you've got the copper ions gain electrons to form copper atoms. So you can put it in words like I've done there, or you can explain the equation as well. So explain the appearance of the copper sulfate solution did not change. So here, what you've got here is when you take copper ions out of the solution, as we just described, you're also adding copper ions into the solution at the anode. So what we can say here is that copper ions are added to the solution from the anode, and that means that the concentration of copper ions does not change. Okay, and again you're going to get 1 mark for each of those 2.